In this lesson, you're going to have an introduction to integers. And before we actually talk about what an integer is, we're going to review a couple of sets of numbers that you should be familiar with, starting with the counting numbers, which are also called natural numbers. These are whole values. And when I say a whole value, I mean that it doesn't include a fraction or a decimal. Whole values starting at 1. And so if we think about what the whole value, the accounting numbers would be, if they start at 1 and they don't include the decimals, well, then it's going to have to be starting at 1 and then 2 and then 3 and then forever in that direction. These 3 little dots mean that it's going to continue on in that direction forever. So they would include 4, 5, 6, 7, 8, 9, 10, etc. Whole numbers are very similar to the counting and natural numbers. Okay, they also don't include fractions or decimals, but unlike counting numbers where they start at 1, whole numbers are whole values starting at 0. Whole values starting at 0. And so if we make our list this time, we're going to have 0, and then that's going to be followed by 1, 2, 3, etc. forever in that direction. Okay, so when we have whole numbers, we gain the number 0. The counting numbers start at 1 and go on forever. With integers, we're going to gain the negative numbers. Okay, integers include all of the numbers that we've talked about. So they include the positive whole values, which were the counting numbers, 0, which we got when we moved into the whole numbers, and negative whole values. Okay, the positive whole values, 0, and the negative whole values. And we can see that right here in this set. Notice there are 3 dots on the left-hand side, 3 dots here on the right-hand side, because the integers continue forever in the negative direction as well as in the positive direction. And again, you can visualize integers as points on a number line like we see below. All of the negative integers, these are your integers that are less than 0, and they're written with a negative sign, and they're always to the left of 0 on your number line. Then you have 0. 0 is neither positive nor negative. It's a neutral number. We call 0 neutral. And then all of the positive integers are integers that are greater than 0. You can write them with a positive symbol or with no sign at all, like they did here. All right, 1, 2, 3, 4, 5, etc. And again, the positive integers are always going to be to the right of 0 on the number line. So based on the information in the number line that we have from above, what kinds of numbers do you think are not integers? Well, we said before with our definition, we can write it back in here again. These are the positive whole numbers, 0, and the negative whole values. And so that means the types of numbers that we haven't discussed yet would be our fractions and decimals. So what numbers are not integers? Fractions and decimals are not integers. Okay, and so some facts or some characteristics that are true about all integers. They must be whole values. They must be whole values. And they do not include fractions or decimals. And so what we're going to do underneath, we're going to give examples of integers in this box. And then over here, we're going to give examples of numbers that are not considered integers. And so for examples of integers, again, it can be positive whole numbers. So that can be numbers like 4 or 17 or 1,000. Okay, 0 is an integer, so we should put that one in our list, 0 as well. And then negative whole values, so numbers like -2, -7, -314, All of those are good examples of integers. Numbers that wouldn't be considered integers, again, integers don't include the fractions or decimals. So we could have a fraction like 1/2, that's not an integer. We could have a decimal like 25 hundredths, that's not an integer. We could have negative fractions like -3/4. We could have negative decimals like -3 and 12 hundredths. We could even have a number that you may have heard of before, which is the number pi. And there's the symbol for pi right there, pi. All right, that's the number 3 and 141592665, etc. Okay, that is definitely not an integer here. You can see that's a decimal that's going to go on forever. Okay, and so that's the difference between what would be considered an integer and what would not be considered an integer. Now that we're familiar with what an integer is, we're going to use integers to represent real life situations. And when we've got words like these, we've got to pay attention to our keywords to help us figure out if we're dealing with a negative integer, a positive integer, or the neutral 0. So in letter A, it says 7 degrees below 0. Our keyword here is that it's going to be below 0, which is going to indicate a negative number. And so the integer that we would use here would be -7. That represents 7 degrees below 0. In part B, a gain of 5 yards. They have gained 5 yards on the play. That's going to be an increase, and so we know that's going to be a positive integer. So we can just write the number 5 like that, or we said before that you could write it with the positive symbol if you wanted to. In letter C, 1,427 feet above sea level, above being our keyword this time, indicating that it's going to be a positive number. And so again, we can just write 1,427. And then in letter D, a debt of $10. A debt. When you're in debt, that means that you owe money. It's money that you don't have. And so it's going to be represented with a negative number. So the integer -10 would be used to represent a debt of $10. In example number 3, they want us to graph the number 3 on the number line and then graph the opposite of 3 on the number line. Whenever they ask you to graph something on the number line, that means you need to find where its location is, and you're going to put a little dot on the number line where that number is located. So it first says graph the number 3 on the number line. Here on the number line is where we see 3. This is the number line here. So I'm going to put a dot right there on the number line. I'm not going to put it floating above the number line. I'm not going to put it below, but actually right on the number line. There we have just graphed the number 3. Now it says to graph the opposite of 3 on the number line, and so we have to know what the opposite of 3 is. Well, the opposite of 3 is going to be -3. And so I find where -3 is located on the number line, and to graph it, I simply just put a little dot where I see -3 on the number line. In example number 4, they want us to graph the number -5 on the number line and then graph the opposite of -5 on the number line. So I'm going to start by finding where -5 is located, which is found right here all the way to the left of this on this number line. And again, I'm just going to put a little dot right on the number line where the -5 is located. And now I need to know, well, what is the opposite of -5? Well, the opposite of -5 is going to end up being +5. And so now I need to find where that's located. That's all the way over here to the right on this number line. And again, I'm just going to put a little dot on the number line where that number is located. Okay, and so based on the last 2 examples that we've done, we need to come up with a definition for opposites. And looking at this number line, well, -5 and +5 are opposites. And the reason why is because if we look at this distance here from 0, from -5 to 0, that's a distance of 5 units. And if I do the same thing from 0 to +5, that is also a distance of 5 units. Okay, since these 2 numbers are the same distance away from 0, they're each 5 units away from 0, they're considered opposites. And so that's what our definition for opposites is going to be. Numbers, these are numbers that are the same distance, numbers that are the same distance from 0. Okay, and so underneath now in example number 5, they want you to give the opposite of each number. And so for letter A, the number is 8, 8 is 8 units away from 0. The opposite would have to be -8 because that is also 8 units away from 0. In letter B, -215, that's 215 units away from 0. The opposite would have to be +215 because that is also 215 units away from 0. And in letter C, the number is 0. Well, the opposite of 0, it's just 0. 0 is already at 0. There is no distance that you need to move in order to get to 0. This leads us nicely into something called absolute value. A number's distance from 0 is called absolute value. So when I talk about absolute value, I'm referencing how far a number is from 0. Now, I want you to put a little star next to this statement right here. Distance cannot be negative. It is simply a value. Okay, and when we have symbols, I'm going to use these bars right here, these bars, and then there's going to be some value inside, and that symbol means the absolute value of n, whatever the value of n is. And so looking at the pictures that we have here, notice that 2 is the number inside of the bars here. The absolute value of 2 is 2 because the number 2 is 2 units away from 0 on the number line. In this example, the number inside of the bars is -1 4/10. The absolute value of -1 4/10 is 1 4/10 because we can see this time it's 1 4/10 units to the left of 0 on the number line. Okay, -1 4/10 is 1 4/10 units from 0. Distance is always positive. The absolute value of -1 4/10 is 1 4/10. Don't confuse that with opposites. In example number 6, the opposite of the opposite of 4 is -4. But the absolute value of 4 is 4 because 4 is 4 units away from 0 on the number line. The absolute value of -4 is also 4 because it is 4 units away from 0 on the number line. In example 7, we're going to try to find the absolute value of these values here, of these numbers here. The absolute value of -13 is 13. It's 13 units away from 0. The absolute value of 9 is 9. It's 9 units away from 0. Notice in letter C, we've got a negative symbol on the outside. We're going to deal with that in just a moment. First, we're going to take the absolute value of -8. The absolute value of -8 is 8 because it's 8 units away from 0. And now we're going to apply that negative symbol to the answer. And so negative, the absolute value of -8, is -8. In my last example, I want to figure out the value or values for n. Notice that n is inside of the absolute value bars. The absolute value of n is equal to 9. I need to figure out what value or values are 9 units away from 0 on the number line. And so I'm just going to sketch a little number line underneath, and I'll put 0 in the middle here. Okay, and I'm trying to figure out a number that's 9 units away from 0. And logically, the first one that comes to mind is the actual number 9. All right, 9, I can see right here, is 9 units away. 9 is 9 units away, and it's 9 units to the right of 0. And so I've got to ask myself, is there another number that would also be 9 units away? And there is. If instead of moving 9 units to the right of 0, I could move 9 units to the left of 0, and that would give me the value of -9. -9 is also 9 units away from 0. And so in this example, the value of n could either be 9 or -9. 9 or -9. And it says to explain your answer, the reason why 9 and -9 are each 9 units away from 0, just in opposite directions. Okay, remember, distance can only be a positive value. So if I went 9 units to the left, I'm going to have the number -9, but that distance from 0 is 9. Or if I went 9 units to the right, I'm going to be at +9. That distance, that absolute value, is also going to be 9.